Solid State Part 3, presented by G. Satyanarayana Gaur, Assistant Professor, Department of Chemistry, Dr. B.R. Government College, Jadcherla. In this lesson, we discuss about derivation of Bragg's equation, Bragg's method to determine interplanar distance, crystal Fowler method, determination of crystal structure by Bragg's law, structure of sodium chloride lattice, structure of potassium chloride lattice, and also we discuss some problems. Let me see about the derivation of Bragg's equation. We know that Max Born law stated that only X-rays will produce diffraction bands in the crystals. Why? Because the wavelength of X-rays are in the order of interplanar distance that existing in the crystal lattice. That's why only X-rays will produce the diffraction bands. If the X-rays are allowed to pass on the crystal surface, the X-rays are allowed to fall on the surface of the crystal, that is on the surface of the planes of the crystals. So they produce the diffraction bands. Here you see this case. In this diagram, we call it as a Bragg's method. In this one, these are the pair of X-rays. The first one and second one. The pair of X-rays are falling on successive planes which are existing in the crystal lattice. So this is the interplanar distance. We say this distance is d, small d, represented by small d. Whereas we say these blue colored lines are nothing but these are the crystal planes. This is the first plane and this is the second one. So on these planes, what is happening? Here the X-rays are diffracting from the successive planes of the crystal. Next, these are reflecting from the planes of the crystal, and again they are produced like this, and they are allowed to record on the photographic plate. Here we place the photographic plate, is it? So the monochromatic X-rays are allowed to fall on surface of the crystal planes which are present in adjacent position in the crystals with the angle of incidence theta. Here you can see what is the angle of incidence. Here it is theta. Now they are diffracted. So here two choices are there. Here two choices we say it is. What they are? The first one is these X-rays may produce these X-rays may cause destructive interference, or they may cause constructive interference. So the first case is when they result the destructive interference. If these X-rays are falling on surface of the successive planes of the crystal and they are reflecting from the planes, during this, if these X-rays are not in a phase, then we say the results destructive interference. We say they are out of phase. When these X-rays are out of phase, is it? They result destructive interference. Instead of it, suppose if they cause constructive interference, it gives a bright bands. When they give a constructive interference, the constructive interference is resulted when these X-rays are in a phase. So if they are out of phase, it results destructive interference. If they are in a phase, they cause constructive interference. In constructive interference, we see the formation of bright bands that can be recorded on photographic plate. So these X-rays are, let's say, causing what constructive interference means. These two X-rays are in a phase. They are in a phase. Is it? These two X-rays are in a phase. Next Next, in order to be in the phase, is it? In order to be in a phase, the extra distance traveled by the second X-ray. Have we identified the extra distance traveled by the second X-ray? Now you see, up to this mark, both of these rays are traveling the same distance from the source. After this also, this mark also, they are traveling the same distance up to the photographic plate. Next, the extra distance traveled by the second X-ray is this one, that is AO plus OB. The extra distance traveled by the second X-ray will be equal to AO plus OB. That is extra distance traveled by the second X-ray. This extra distance traveled by the second X-ray must be an integral multiple of wavelength of X-rays. What is the condition? The extra distance traveled by the second X-ray must be an integral multiple of wavelength of X-rays. Then only we say this ray 1 and ray 2 X-rays, these two rays are present in a phase. If it is not such like that, means if it is not an integral multiple of wavelength of X-ray, we say both of these rays are out of a phase and they cause destructive interference. So now here we are observing the condition of what? Constructive interference to record the bright bands on photographic plate. That's why, what is the condition? The extra distance traveled by the second X-ray must be an integral multiple of wavelength of X-rays. So this AO plus OB is the extra distance. That must be the integral multiple of what? It is lambda. Now we have to express this AO and OB in terms of angle of incidence. Angle of incident. What is the angle of incidence? You see, this is theta B. Angle of incidence is theta B. It is also theta B, is it? According to the properties of parallel lines, straight lines, properties of the parallel straight lines, we say this angle is also equal to theta B. This angle is also equal to theta B. Similarly, this angle is also equal to theta B. That is angle of incidence. So angle of incidence, this is theta B, is equal to this one, and also this equation will be, this angle will be equal to this one. So in this triangle, you see, here we can find a triangle. Two triangles are there. Let you observe this first triangle. In this triangle, this is the interplanar distance D. Okay, this is the interplanar distance D. Okay, next this is the angle of incidence. Now in this case, if we calculate sine theta will be equal to OA divided by, this is let's say it is G or O, this point from this distance is it. So this theta B, sine theta B is equal to AO, and this is what, divided by D. Similarly, here in this triangle, the second triangle also, we say sine theta will be equal to, this sine theta will be equal to, it is OB divided by D. From this, if we calculate for AO and OB, what is AO? From this it is D sine theta. AO will be equal to D sine theta. Similarly, OB will be equal to D sine theta. What is extra distance traveled by the second X-ray? It is equal to AO plus OB. So the extra distance traveled by the second X-ray is equal to AO plus OB. So AO plus OB is equal to D sine theta plus D sine theta. How much we get? We get 2D sine theta. So in order to occur a constructive interference or bright bands on the photographic plate, what is the condition? The condition is this extra distance traveled by the second X-ray must be an integral multiple of wavelength of X-ray. So what is the extra distance traveled by the second X-ray in terms of this theta, angle of incidence? We say it is 2D sine theta. Therefore, we say 2D sine theta is equal to n lambda. This is called Bragg's equation, we call Bragg's equation. If this is at n is equal to what? 1, 2, 3, 4, like that is it. If n is equal to 1, we say it is first order diffraction. If n is equal to 2, second order diffraction, and so on. Like this, with help of the Bragg's equation, we can find the interplanar distance. How we can find? by substituting n is equal to 1 or 2 or 3 or 4 depending on the what order of diffraction, and lambda is the wavelength of X-rays. Okay, theta is angle of incidence, so that you can calculate d. Only d is the unknown factor you can calculate. So what is use of Bragg's law? We can determine the interplanar distance by this Bragg's equation. Okay, so this is a derivation of Bragg's equation. What is the first point? In order to occur the constructive interference, what is the condition? The two X-rays must be in a phase. In order to be present in a phase, what is the condition here again? The extra distance which is traveled by the second X-ray must be an integral multiple of wavelength of X-rays. Okay, and again we are calculating AO plus OB distance. This AO or OB, whatever, AO or OB, it is equal to d sine theta. If you add to these two distances, we say it is AO plus OB, that is equal to 2d sine theta. We got it is as n lambda. It must be equal to n lambda. This is about the what we say it is. This is about Bragg's equation. What is the use of Bragg's equation? We can find the interplanar distance. Next, we discuss about the determination of structure of crystal by Bragg's method. How to determine this experimental method? The name of the experimental method is Bragg's method. You can see the how the operators are arranged in this experiment. It is the X-ray tube which produces the X-rays. They are the collimators which can reduce the number of rays. Means a beam of X-ray now becomes, that is a beam of it will be reduced, the number of X-rays will be reduced here. It is traveling to the slit, and now what we are taking here is a crystal is placed. You see, a crystal which is having the perfect planes, it is placed on the table which can rotate by 360 degrees angle. The crystal will be mounted on a table which can rotate by 360 degrees angle. Now the reflected X-rays will again enter into diffracted X-rays, will enter into the detector. This detector, you remember, will contain either methyl bromide or sulfur dioxide. When the X-rays enter into the detector, actually it is ionization chamber. Ionization chamber. When the detector contains ionization chamber. So the X-rays are entering into the ionization chamber. The vapors of methyl bromide or sulfur dioxide will be present here. When the X-rays enters into this ionization chamber, methyl bromide or sulfur dioxide molecules will get ionized. So that will be finally connected to the electrometer. That is the detector. Now the detector will identify the peaks or angle of incidence where the maxima is observed. So this is about the arrangement. Is it X-ray tube? It produces the X-rays. The number of X-rays can be reduced. Now it is traveled to the slit. We say it is collimators. Now it is allowed to fall on the surface of the crystal. Remember, the crystal is placed on the table which can rotate by 360 degrees angle. You can rotate it. Now the X-rays are reflecting from the crystal with angle, you remember, with angle 2 theta. This X-rays will be entered into ionization chamber which contains methyl bromide or sulfur dioxide. Because of these X-rays, in presence of X-rays, methyl bromide or sulfur dioxide will undergo ionization, whereas the ionization chamber will be connected to electrometer. We call total device as a detector. Now the detector will identify the signal. This is about the instrumentation of Bragg's method. Here you can see the X-rays are falling on the surface of the crystal plane with theta angle, but whereas the reflected angle is observed by 2 theta. Here you can see very easy. These are X-rays. Now the X-rays are allowed to fall on the surface of the crystal plane. Now they are reflecting like this. So here X-ray detector is there. is it? For example, if X-rays are not reflected, if they are traveled in a straight line, what will be the position? You see, this X-rays now will travel like this actually. But here what is happening? The X-rays are reflecting from the plane. How it is reflecting, you see? The X-rays are traveling like this and it is reflecting here. What is the angle of incidence? Actually, angle of incidence would be only theta. Here it is theta. But angle of reflection will be 2 theta. So in case of Bragg's method, we measure 2 theta value. We measure the 2 theta value. Okay, this is about the Bragg's method. So what are the substances used in the ionization chamber? It may be the methyl bromide or sulfur dioxide. So when the X-rays cause consecutive interference, the more number of X-rays will travel and reflected and they will enter into the ionization chamber. Greater the intensity of X-rays enter into the ionization chamber, greater will be the what we say height of the peak we observe. That is, greater will be the intensity we observe. Means here the extent of ionization of methyl bromide or sulfur dioxide depends on the intensity of X-rays which enter into the ionization chamber. Okay, so the ionization will be observed only for consecutive interference, not for the destructive interference. That you have to remember. Second point is, what you have to remember? The angle of incidence is theta, but angle of reflection, diffraction, angle of diffraction will be equal to 2 theta. So we get 2 theta value in this. Now, how to identify n is equal to 1, n is equal to 2 like that? The lowest angle at which maximum reflection occurs, that is n is equal to 1. Lowest angle at which maximum reflection occurs, that represents n is equal to 1, that is first order diffraction. Like this, we can measure the theta value. Now, drawing the graph between theta versus 2 theta versus intensity, 2 theta versus intensity, so that intensity, so that we can see the graphs will be like this. Is it the type of graphs will be observed? We will see in the later discussion. This is about the Bragg's method. Second method is, you see what are the important points in the Bragg's method here we have given. The intensities of reflected rays are measured on a recording device such as photographic plate or ionization chamber. The angles for which reflections are maximum gives the value of theta. Process carried out for each plane by rotating the crystal on a table, because the table is 360 degree, can be rotated by 360 degrees. After observing the theta value from one plane, so that we can rotate the table to measure the theta value for other plane of the crystal. Rather, it can be rotated by 360 degrees. Next point is the lowest angle at which maximum reflection occur corresponds to n, and the next higher angle at which maximum reflection occur is n is equal to 2. Like that, we can identify the first order or second order diffractions in Bragg's method. This is about the Bragg's method. Okay. Next, you see the powder method. So, what are the disadvantages of the Bragg's method? There you have to use the crystal, solid crystal, which is having the perfect planes, and it should be placed on the table and it should be rotated with different angles to measure the reflection from different planes. But in case of powder method, that can be overcome by converting the crystal into fine powder. That is, crystal is made into fine powder and placed in the capillary tube. Here you see a sample of crystal is placed in the capillary tube here, let's say capillary tube. Okay, the crystal is placed made into a fine powder and placed in the capillary tube. Now the X-rays are allowed to diffract on the crystal powder. See, the crystal powder is having the different particles oriented in different directions. Here you can see the different planes are oriented in different directions. These X-rays now will diffract at different angles. Here no need to rotate the crystal powder because the crystal powder is containing many particles in which the crystal planes are oriented in different directions, so that the X-rays diffracted will have the different will diffract with different theta values. Now the crystal powder which is placed in the capillary tube is surrounded by a photographic film, or we say the fluorescent material like zinc sulfide. Is it? Next, it is placed like this, a circular. What mode we will place it as circular method? Is it circular fashion? And here also the angle of incidence will be measured with 2 theta value. Is it? So 2 theta will be equal to here. Here you see, for example, this is the reflection of the X-ray like this. You see, reflection of the X-ray like this, so that you can find the spots on this place as well as this place. Between these two places, you will find the path. But if you see about the angle, you see here it is the first play. This angle of incidence is nothing but what it is, 180 degrees, and whereas this will be the 0 degrees, or you say it is, if it is 0 degrees, this will be the 180 degrees. Is it angles? Because it represents a straight line. So this part belongs to this lower part belongs to 180 degrees. This lower upper part belongs to 180 degrees. So there we can see at some place, depending on the reflection, we can see the formation of bright spots on photographic plate. Now the distance which is recorded on distance between the bright spots means, here you see this spot. This is the distance between the bright spots. Again we can see it clear. Is it? The distance between the bright spots. We said that here is a one spot, second we say here, let's say it is second part. Now we have to see the distance between these two. Yeah, this distance can be converted into angles here. This distance will be converted into angles. So how to convert the distance into the angle, that we see in next slide. So is it clear? So in powder method, the crystal is converted into fine powder and filled in the capillary tube. X-rays are allowed to fall on the surface of the capillary tube. Since the crystal powder is containing many particles which are oriented in many directions, different planes will be oriented in different directions. So we will observe the reflection of X-ray from with a different different angles. So the X-ray spots will be observed on the, or will be recorded in the photographic plate, or it is a fluorescent film which is arranged around the capillary tube in circular fashion. So the spots on the photographic plate, we can measure the distance between the spots, and this distance can be converted into, again, angles. Let me see how to convert. Again, we are explaining some important points here regarding the powder method. So crystal powder contains many small crystals oriented in possible directions. Okay, it is oriented in possible directions, right? So X-ray scatter from all sets of lanes and detected on the X-ray sensitive film. No rotation is necessary in this. We observe the lighted areas on the film at different distances from the incident beam, and these distances are converted into scattered angles, which are used in the Bragg's equation for calculation of DHKL. What is DHKL? It represents the plane. Here you see this is the capillary tube. Now the X-rays are reflecting in this different modes. Many reflections we can see depending on the planes of the crystal which are present in the crystal powder. Like this, we can see the different reflections. Is it? Now these different reflections can be converted into, the distance will be measured and that distance will be converted into angle. We use this formula to convert the distance into angle. L divided by 2 pi r, that is equal to 2 theta by 360. You see, the L divided by 2 pi r. 2 pi r means the total, this one, it is equal to 2 pi r. Now in this, whereas the distance between these two spots will be measured as what? It is L value. Okay, so this L value corresponds to which value here? What is the angle of incidence? We say it is 2 theta. If you convert this L into angle, it will be equal to 2 theta. So here this is 360 degrees, which is equal to 2 pi r. Now this L belongs to 2 theta. Now we are calculating, what you are calculating? Ratio between L and 2 pi r. Similarly, we are calculating ratio between 2 theta and 360. Both of these are equal. Both of these are equal. So this is the equation to calculate to convert the distances which are recorded on the photographic film into angles. What is the formula? L divided by 2 pi r. What is L? L is the distance recorded between two spots of the X-rays. 2 pi r is the total circumference of the photographic plate. That is equal to 2 theta. Theta is the angle of incidence. With the help of this, we can calculate theta, and this theta can be substituted in Bragg's equation to calculate D. This is about the Powder's method. What is the advantage of Powder method? No need to rotate it. Many crystal planes will be oriented in many directions so that we will get all the theta values at once. This is about the crystal powder method. Let us see how to calculate the what we say interplanar distance with help of the Bragg's law. This is a problem. With help of this problem, we can understand. You see the problem. Mercury chloride crystallizes in orthorhombic system. The 100, 010, and 001 reflections in X-ray diffractometer occur at 7 degrees 25 minutes, 3 degrees 28 minutes, and 10 degrees 23 minutes respectively. The wavelength of X-rays is 154 picometers. Calculates the dimensions of unit cell. So how to identify the dimensions of unit cell? You remember, in order to identify the dimensions of unit cell, you have to record the theta values. Okay, next, what is the Bragg's? We solve this problem with help of Bragg's equation. What is the Bragg's equation? 2d sin theta is equal to n lambda. 2d sin theta is equal to n lambda. Here, we say that these reflections are taking place with n is equal to 1. N is equal to 1. That's why we say it is a first order diffraction. N is equal to 1. Substituting n is equal to 1, this 2d HKL sin theta is equal to lambda. What is DHKL? It is the interplanar distance of planes which are indicated by H, K, L Miller indices. Okay, so it said that orthorhombic system where A is not equal to B is not equal to C. Let us see this formula. The interplanar distance already we have discussed in lesson 1. 1 by d square HKL is equal to H by A power 2 plus K by B power 2 plus L by C power 2. What are HKL? They are the Miller indices of the plane. What are ABC? The dimensions of the unit cell. Dimensions of the unit cell. Now we have to calculate the interplanar distance for 100. So let us substitute H is equal to 1. For 100 means H is equal to 1, K is equal to 0, L is equal to 0. Let us substitute here 1 divided by d square 100. What is H? 1 divided by A square plus 0 divided by B square, because K value is 0 here, you see the plane, plus L value 0 again, so 0 by C square. Here A is not equal to B is not equal to C, remember. So 1 divided by A square plus 0 divided by B square plus 0 divided by C square. ABC are the dimensions of the unit cell, whereas 1, 0, 0 are the HKL Miller indices of the plane. So if we calculate, simplify these, We see this becomes 0 and this becomes 0. Simply 1 by d square is equal to 1 by a square, or a is equal to dvc. A is equal to d. So this d100 is equal to, we can, according to Bragg's law, how can we write? Lambda by 2 sine theta. Lambda by 2 sine theta. D100 is equal to lambda by 2 sine theta. And you also remember this D100 is nothing but A. D100 nothing but A means you are calculating the value of A. You see. So A is equal to D100, that is equal to lambda by 2 sine theta. Lambda is 154 picometers. Where 2 sine, what is X-ray diffraction for 100 plane? Here you can see it is 7.7 degrees 25 minutes. You are substituting 2 sine 7 degrees 25 minutes. So if you simplify this, you will get D100 equal to 597 picometers. It is nothing but the value of small a. So you remember, in order to calculate small a, you have to work out for 100 plane. In order to calculate for small b, you have to work out for 010 plane. Similarly, to calculate for c, you have to see for 001 plane. Okay, this is about the problem. And we can calculate the remaining b and c also. You can see this table. These two formulas we are using here to calculate the dimensions of the unit cell. When you are calculating D100 means you are calculating A, you are calculating B here, you are calculating C here. So already we have discussed about this one. Similarly, you see 010, HK value 0, K value 1, L value 0. So formula is, you can see this formula. This formula we are using here. 1 by d square 010 is equal to 0 by a square, h value is 0, plus 1 by b square, k value is 1, plus 0 by c square, L value is 0. Is it? So these values becomes 0. So what is the formula here? D 1 by d square is equal to 1 by b square means d becomes equal to b. Again you are writing for d. D is equal to, it is nothing but b. It is nothing but b. D010 is equal to 154. Again this formula you can see. Lambda 154, that is the wavelength of X-rays, by 2 sine 3 degrees 28 minutes peak. This we are observing in picometers. So this will be obtained as, B value is obtained as 1270 picometers. Similarly, you can calculate for D001, it gives another dimension value C. 1 divided by D square 0101 H0 K0 L1. So only L we substitute. These two parts become 0. So D001 becomes 154. Again, we are using this formula, lambda 154 by 2 sine theta. Theta is 10 degrees 23 minutes. And simplifying this, you can find D001. So what are the dimensions of the orthorhombic unit cell? With the help of the Bragg's law we have calculated. A is equal to 597 picometers, B is equal to 1270 picometers, and C is equal to 434 picometers. Like this, if you know the H, K, L and angle of incidence, you can calculate ABC. Or if you know ABC and HKL value and wavelength of X-rays, so that you can calculate theta. So you can calculate theta. Is it clear? So like this, problems can be observed in this. If you know the value of A, B, C and angle of incidence theta and lambda, you can calculate HKL also. Next, if HKL values are given, lambda and theta are provided, you can calculate ABC also. If HKL values are provided, ABC are provided, lambda is provided, you can calculate theta also. Different problems, different types of problems can be solved in this case. It's clear how to solve A, B, C. In order to calculate A, you have to calculate the D100. In order to calculate B, you have to see D010. In order to calculate C, you have to see D001. Next, another problem you can see here. Potassium nitrate crystallizes in orthorhombic again with unit cell dimensions. Here unit cell dimensions are given: A 542 picometers, B 917 picometers, C 645 picometers. The wavelength of X-rays is given 154.1 picometer. Try to calculate the diffracted angles for first order X-ray reflections from 100, 010 and 110 planes. So this should be not 11, 111 is 111 place. This is a problem given. So already calculate for, so in previous problem, angle of incidence was given from different planes. We have calculated ABC. But here ABC are given and asking to calculate angle of incidence from different planes. So let us calculate the angle of incidence from D100 plane. Again, what is the formula? 1 by D square is equal to H by A power 2 plus K by B power 2 plus L by C power 2. We know that formula. So let us substitute 1 by D square 100, 1 divided by, because what is H value? H value is 1. So 1 divided by A value is given to us, you see. A value is given here. 1 by 542 square plus what is the value of K? Miller index is 0 by B square plus 0 by C square. These two become 0. So what is D100? 542 picometers. You got it. So now you have to calculate for sin theta. What is sin theta? Lambda by 2D. Is it from Bragg's equation? Because n is equal to 1, we have substituted. 2D sin theta is equal to n lambda, n is equal to 1. So sin theta becomes equal to lambda by 2D. What is lambda value? 154.1 divided by 2D. 2 into 542. This is the distance, the interplanar distance. It is nothing but A. We got 0.142. So what is sin theta? It is 0.142. So theta will be equal to sin inverse 0.142. In sin inverse table, we can see this value. It will be 8 degrees, 10 minutes. Okay, like this we can see. Similarly, we can calculate D010, H0, K1, L0. So 1 by D square is 0, 1, 0, 0 by A square plus K is 1, is it? 1 by 917 square plus 0 by C square. So D, we got it is 917 picometers. So sin theta is equal to lambda by 2D. We are calculating sin theta, means angle of incidence for this plane. Lambda, how much? 154.1. Lambda is 154.1 by 2 into D. D is interplanar distance, 917 picometers. We got it is 0.084. So sin theta is equal to 0.084. What is theta? Sin inverse 0.084. We got 4 degrees 49 minutes. This is angle of incidence from D010 plane. Let me calculate for D111 plane, is it? D111 plane. What is H value? 1, K value 1, L value is also 1. We know A, B and C values. Let us substitute 1 by D square triple 1, 1, 1, 1 is equal to H value 1 by 542 A square plus K value 1 divided by B value is 917 square plus C 645 square. So on simplifying this factor, we get D111 will be equal to 434 picometers. It is interplanar distance. So now sin theta is equal to lambda by 2D. By substituting the lambda 154.1 divided by 2 into D, distance is this one, 434, that is 0.204 we got. So sin theta is equal to 0.204. What is theta? That is equal to sin inverse 0.204. So the theta is calculated 11 degrees 46 minutes. Like this, when ABC values are given, you can calculate angle of incidence. If the angle of incidence are given, you can calculate ABC. That's the dimensions of unit cell with help of Bragg's equation and with help of the equation for interplanar distance. Now, how to determine the crystal structure by Bragg's law? It may be the powder method or Bragg's method. We record the theta values from different planes. Here, the angle of incidence should be recorded from planes 100, 110 and 111, planes of the different systems. Means, for example, we want to determine the crystal structure of a given crystal. In order to determine the crystal structure of a given crystal, we have to perform the Bragg's experiment. There we have to observe the angle of incidence of these planes. What are the planes? 100 plane, 110 plane and 111 plane. And with help of Bragg's equation, we can calculate the interplanar distances. Just now we have discussed in the problem. So for example, if it is a simple cubic system, the given crystal system is a simple cubic. If we calculate the ratio between these distances, D100 plane, D110 plane is to D111 plane, that will be equal to 1 is to 0.707 is to 0.577. Means it will be 1 is to 1 by root 2 is to 1 by root 3 like that. It is 1 is to 0.707 is to 0.577. They are the reference values. Similarly, if the given crystal is having the face-centered system, cubic system, again the ratio between these interplanar distances of each plane, which planes? 100, 110 and 111. Then it will be 1 is to 1 by root 2 is to 2 by root 3. We got this. 1 is to 0.707 is to 1.154. Similarly, in case of a body-centered cubic system, the ratio between the interplanar distances of 100 is to 110 is to 111 will be equal to 1 is to root 2 is to 1 by root 3. Then we got this. 1 is to 1.414 is to 0.577. So these are the reference values. You see, the intense reflections are identified by the X-ray spectrometer. Ratio of lattice spacings for various groups of planes can be obtained. This ratio will be different for different crystals. This is important. This ratio will be different for different crystals. And comparing with the standard ratio, the structure can be determined. So we say these are the standard ratios. For simple cubic, what is the standard ratio? That is the ratio between the interplanar distances. What are the interplanar distances we are observing? 100, 110, 111. So ratio between these interplanar distances in case of simple cubic system, once again 1 is to 0.707 is to 0.577. Similarly, in case of a centered cubic cell, the ratio is, that is 1 is to 0.707 is to 1.154. In the case of body centered cubic cell, what is the ratio? It is 1 is to 1.414 is to 0.577. Like this, we can determine the crystal structure by Bragg's method. Means you have to calculate these interplanar distances. So that these are the given values are the standard values. You compare those obtained values, experimentally obtained values with these standard values, and you can see, or you can identify the type of crystal system. This is about the determination of crystal structure by Bragg's method. Okay, so what we have discussed today? We have discussed about the derivation of Bragg's law. Second, we have discussed about the Bragg's method to determine the interplanar distance. The third one, we have discussed the crystal powder method, and we are solving the problems. We have solved some problems. Okay, so in case of a simple cubic system, you see, simple cubic system ratio is 1 is to 0.707 is to 0.577. NaCl, we know that it is phase anti-cubic cell. So in case of NaCl, if you calculate the interplanar distance, you will get 1 is to 0.707 is to 1.154. Similarly, in the case of KCl also, we get this 1 is to 0.707 is to 1.154. Means NaCl and KCl, both of these are having phase anti-cubic cell that we will see in the next class. Thank you.